Hey guys, what's up everybody? Welcome and welcome back again to another video tutorial from the Apex Academy of Mathematics, where learning the language of the universe begins here. On this channel, we rebuild students, we help them to master their fundamentals, and we unlock the genius that lies within them. Now, if this is the first time here on my channel, or you have watched previous videos on my channel, of course, you know what you're going to be expecting, or you know what you're expecting, and you're about to get it. Please go ahead and like the video and smash the subscribe button and turn on your post notification bell. For those of you for the first time, my name is Akeen, otherwise known as Apex LMU, and let's jump right into the video. Alright, now please be advised that this video, of course, is for the basics of CXC and of course other major exams like GCE, SAT, ED, exams, and any exam that is across the world that has to do with indices. This video is or can be to your benefit. All right, so do watch this video to its entirety, and of course, if you're getting some value, don't be afraid to leave a comment below if you like what's happening. All right, so hope I can help you with this today. All right, now let's jump into the video where we're going to be talking about simplification of indices by changing the base technique. All right, now this is a very I should say a really good skill to have. All right, it of course is not an skill that you can earn overnight. It takes practice like everything else, and of course it is the fundamentals of indices, but of course you are going to need to know their very basic fundamentals. All right, so let's look at what you need to have to start off. All right, you need to know your square table and you need to know your cube table. I've made previous videos using what is called the manipulation technique and talking about the square table. Do check the description box below for links to those videos so you can have an idea of explanations that I've given as it relates to knowing your square table. All right, so let's look at this here. It says that one of the most valuable skills needed to do problems like the ones I'm about to show you are the ability to know your square table and your cube table, along with the exponential or exponent manipulation technique. This thing right here, I have a video that is on my channel that I've already made as it relates to manipulating exponents. So of course, if you see anything that is strange and you don't understand, revisit that video to know exactly what I am doing. All right, good. So this video is for those who have already watched that video. If you have not, go right ahead and go and watch that video. If not, continue to see what is going to be done here. All right, so we are already familiar with our square table and our cube table. Let's use this to our benefit and take a look at some questions like these. All right, so here are some basic examples to start us off. All right, we have base numbers with rational powers. All right, so we know that here 5 squared is equal to 25. All right, so we can basically change 5 squared 25 here to mean 5 squared. All right, 5, and then we're going to multiply that by a half. All right, let's just write this 5 a little bit better for you. Okay, and then the 2 will cancel the 2 and you're left with 5. So 25 to the power of a half is equal to 5. That was easy, wasn't it? Yeah, it is once you know your square table. Let's take a look at the number 8. Now 8 is a number, special number that is on our cube table. So if you remember, 8 is really 2 cubes. All right, so 2 cubes times a third, the 3 cancels, and there you have the number 2. So 8 to the power of 1/3 is equal to 2. All right, that isn't too bad at all. All right, now let's take a look at the number 81. 81 is on our square table, and we know that that is basically 9 squared, but we have to multiply it again by 3 to the power of 2. So that cancels here, and we get our final answer of 9 cubes, which we know is 729. All right, really nice. Let's take a look at 125 to the power of 4 over 3. 125 is on our cube table. This is 5 cubes. And of course, that's times 4 over 3. That cancels. So we end up with a final answer of 5 to the power of 4, which is actually equal to 625. So 125 raised to the power of 4 over 3 is 625. Now, what I want to demonstrate to you here is that if you want to, one of the easiest ways to work these questions out is to look at the denominator of the power. And then you're going to know that the base here must be a number that is raised to a power, because the ultimate objective here is to cancel the denominator. If you cancel the denominator, your numerator will just be an integer power. So it's easy to work out once you get rid of that bottom denominator. So that's how I know that I need to find a number that I can square to get 25, find a number that I can cube to get 8, find a number that I can square to get 81, find a number that I can cube to get 125. So that is how I was able to determine these. And of course, see, I was not using the table that I have over here because I already have these in my head, so it was really easy for me to work these out. Now I really want to draw your attention to some other examples. All right, some other strange looking examples. So there are some numbers that if you don't memorize the exponents and you know how to manipulate these base, can be quite tricky. All right, so sometimes the power won't, sometimes the number that is down here won't be a number that you can raise the base to. Okay, so for example, 32 is not a square number and it's not a cube number, but we want to try to get rid of the 5. So what number can I raise to the power of 5 in order to get 32? Now, sometimes it's really good to know what that exponential quantity is, but if you don't know, there are techniques that I can help you with. Now, what you want to do here is that you want to check the number 32 here. And you want to see, try a number, just try any number that can go into 32. I will always start with the lowest. All right, so I will start, of course, with the number 2. I want to use a prime number actually. So 2 into 32, 16, 2 into 16, 8, 2 into 8, 4, 2 into 4, 2, and 2 into 1, 2 into 2, 1. All right, now what I notice here is that there are 5 2's at the side. So this is 2 times 2 times 2 times 2 times 2. That's 5 2's. So what I recognize here is that if I can multiply 2 by itself 5 times, I will get 32. Then it would simply mean that 2 to the power of 5 is equal to 32. Now that was an easy one because the first number I chose gave me my answer. So that works. All right, so what I recognize here is that 2 to the power of 5 here, 2 to the power of 5 multiplied by 3 over 2, 3 over 5, I'm sorry, and then the 5 cancel the 5 and I end up with 2 to the power of 3. That's really nice. So it really works out nicely for you, all right, once you know what 32 is. And it's a strange base, but it's a familiar base for most math students. So we learned that 2 to the power of 3 here is actually equal to 8. So that works out nicely for you. All right, so do remember that 2 to the power of 5 is actually equal to 32. All right, now 256. This problem can be worked out longer than it has to, because if you don't know that 4 to the power of 4 is 256, you may have to use a different technique. So I'm going to use that method first, that longer method, then I'm going to shorten it for you. All right, so right off the bat we know that 256 is actually equal to 16 squared. All right, so 16 squared, and we're going to multiply that by a quarter. So here's what's happening is that we can reduce the denominator, but we cannot get rid of it completely. So we're gonna have to do that first. So that 2 cancels into that 4 and leave us with 2 there. So we end up with 16 to the power of a half. All right, and then we know that 16 is actually equal to 4 squared. So 4 squared times a half, and that cancels. and so your answer is 4 to the power of 1, which is equal to 4. So you see how long it is. Your ability to work out a math problem fast is highly dependent on how much your skill level and how much you know about number manipulation. Now this method here is long in comparison to the fact that if you knew from your memorization skills that 4 to the power of 4 is 256, then all you had to do was just times it by a quarter, cancel, and then you're going to get your answer that is equal to 4. All right, so in one line I could have gotten the answer, but you can only do this only if you knew that 4 to the power of 4 is 256. So you can check my manipulation technique video for exponents. A link is in the description below, so do that, and then you can see exactly how you can use that skill to your advantage. If not, you're gonna have to commit this to memory. There is no going around it. All right, really good. All right, so let's look at 128. Now that of course doesn't look like a very familiar base, so we're gonna have to try to figure out what is this 128. Once again, as I recommend, write down the 128 and choose the lowest prime number and see if you can get 7 of that number at the side. All right, so let's see, 2 here, so 2 here. All right, let's write that a little bit smaller. And so 2 into 128, 64. 2 into 64, 32. 2 into 32, 16. 2 into 16, 8. 2 into 8, 4. 2 into 4, 2. 2 into 2, 1. Let's see, 1, 2, 3, 4, 5, 6, 7. It works out again that the very first number that I have chosen, 2, works out to have 7 at the side, 7 2s at the side. So right away I know that 2 to the power of 7 is actually equal to 128. All right, so 2 to the power of 7 is equal to 128. So I can just simply say here 2 to the power of 7 times 3 over 7, and that 7 cancels here, so that's 2 to the 3, and that's equal to 8. All right, very good. So I hope you guys got that little trick right there. Let's look at 243 to the power of 4/5. All right, so you will need to know off the top of your head that 3 to the power of 5 is equal to 243. All right, and I'm going to times by 4/5, so that will cancel here, and I end up with 3 to the power of 4. And when we work that out, you're going to see that you get the answer of 81. So that was quite simple. But once again, this video is not to just show you what the answer is, but it's to show you how I got there. So once again, we want to look at the fact that 243, we have to choose a number that we think that can go into 243. All right, now it doesn't look like 2 can go into 243, so we're gonna have to choose a different number. Let's try 3. All right, so 3 into 343, if you go on your calculator, you should get 81. And of course 3 into 81, if you go on your calculator, you're going to get 27. And 3 into 27, that you go on your calculator, you're going to get 9. Okay, you're going to get 9. And 3 into 9, you're going to get 3. 3 into 3, you're going to get 1. So you can see here that 3 times 3 times 3 times 3 times 3, that's 5 3s. That is how I knew that 3 to the power of 5 is 243. And of course, that is how I got to that part. So it's really good that you know how to manipulate numbers, and I cannot emphasize anymore that you need to learn it. The faster you learn it, it's the better it will be for questions like these. All right, let's look at 625 to the power of 3/4. All right, so once again, you can try that technique. Try a number that can go into 625. It doesn't look like 2 or 3. You could try 5 and see what happens. But then I already know that 5 to the power of 4 is equal to 625. And I'm going to times that by 3 over 4. And when I cancel that, I'm going to get 5, 3. That's equal to 125. Okay, I already knew that. Right, that 5 to the power of 4 is equal to 625. 729 to the power of 1 over 6. I already know that 3 to the power of 6 is 729. Again, you can try dividing that number by 3. You can try dividing it by 9 and see if you get 6 of those numbers at the side. If that happens, then you should end up with 3 6s at the side, and then you know that 3 to the power of 6 is 729. Now if I multiply that by 1/6, I cancel that, my answer is going to be 3. All right, so that's really useful technique right there. All right, so I hope you guys are enjoying the content so far. If you are, go ahead and smash a like for me and support my channel and help me share this video with persons right across the world. All right, good. So let's get into it now. The final aspect of this video here is we're going to be talking about fractional quantities that have fractional powers. All right, so let's use this skill that we already have here. We have 4 over 25. I kind of want to rewrite this for you because most of the time this is not how it's written on exam papers. So it's normally written like 4 over 25 all raised to the minus 3 over 2. All right, let's go on the next page and see how that works out. So here I'm gonna just erase everything here. So we have 4 over 25 raised to the, let's check it over here, it's going to be negative 3 over 2. Negative 3 over 2. Now to work this, if we remember the negative index property or the negative power property, we know that we're gonna have to turn this number upside down and change the power from negative to positive. So that's the very first step that we have to do. Now once that happens, recognizing that 25 is equal to 5 squared and 4 is 2 squared, and we're going to all raise that to 3 over 2. All right, now power to power property says that the power will distribute itself on the inside. So we have 5 squared times 3 over 2, and that's divided by 2 squared times 3 over 2. Notice now that this 2 cancels that 2 and that 2 cancels that 2, so we end up with a final answer here of 5 cubed is 125, and of course 2 cubes is 8. So finally we look at the fact that 4 over 25 raised to the minus 3 over 2 is actually equal to 125 over 8. So I hope you guys got that part. All right, good. So let's look at the final 2 or 3 examples that is left. So here what we have now is, let's go back to this page here. We have 27 over 8 raised to the 2/3. 27 over 8 raised to the 2/3. All right, so let's write that here for you. 27 over 8 raised to the 2/3. That's a positive 2/3. Now we do not need to reciprocate because the power is already positive, so we can just go ahead and do our change of base. So we can change this. We need a number that is raised to a power of 3, so that sounds like 3 cubes, and we need to change the 8 to a number that can be raised to a power of 3, that is 2 cubes. Now that's 2 over 3 here. All right, so power to power property, that's going to be 3 to the 3 multiplied by 2 over 3 divided by 2 to the 3 multiplied by 2 over 3. All right, and nicely you can see that that 3 cancels that 3, that 3 cancels that 3, so we end up with 3 squared over 2 squared, and that's equal to 9 over 4. Okay, 3 squared is 9 and 2 squared is 4. All right, so 27 over 8 raised to the 2/3 is actually equal to 9 over 4. All right, so I hope you guys are getting the concept so far. You see how really good and how easy these problems can be if it is that you know your square table and your manipulation technique. All right, let's look at another one. We have 16 over 81 raised to the minus 3/4. All right, so 16 over 81 here raised to the minus 3/4. All right, so it, as I said, it really helps when you know your square table and your cube table, and knowing how to converge them and manipulate what you already know. So here, without further ado, I know that 8 squared is 16, but I also know that 2 to the power of 4 is actually equal to 16. I know that 9 squared is 81, but I also know that 3 to the power of 4 is actually equal to 81, and I'm going to raise that to the minus 3/4. Now you must be saying then, Akin, why didn't you reciprocate first and then do the change of base? You can do either one first. All right, I just immediately recognized that 16 and 81 are not going to, we're not going to be using the regular square and cube numbers to change them, so my brain automatically saw that problem first. Now the next thing I'm looking at is the fact that my power is negative, so I need to switch and reciprocate the base, the quantity, the numerator and the denominator, and change the power to 3/4. Now after I've done that, now clearly you can see that power to power property, 3 to the power of 4 multiplied by 3 over 4, and that's divided by 2 to the power of 4 multiplied by 3 over 4, and then that 4 cancels that 4, and that 4 cancels that 4, so I end up with an answer of 3 cubes over 2 cube, which is actually equal to 27 over 8. All right, 3 cubes is 27, 2 cubes is 8. All right, so I really hope that if you're watching this video, this is a problem that you have always seen and you have always not known how to do it, but now it's becoming a lot clearer for you. That's the objective of this video. Let's wrap this up with the final question. 64 over 729 raised to the minus 5 over 6. 64 over 729 raised to the minus 5 over 6. All right. All right, good. So wonderful. Let's take a look at that. Now, as you would have already known, that 64 has 3 different exponential expressions. We have 64 as being 8 squared, 64 as being 4 cubed, and we also know that 64 is 2 to the power of 6. So I want to use the exponential expression that has the 6. I'm going to use 2 to the power of 6 for 64. All right, now I know that 729 is 9 cubed. I know that 729 is 27 squared, but I also know that 729 is 3 to the power of 6. All right, so I always want to use the one with the 6 because my denominator in my power here is 6. It makes my cancellation a lot easier. Now, not to say that if you use a different one, it won't work. It will work, it just will take you a little bit longer to get to your answer. All right, so we want to make sure that that works out for you. All right, so that's going to be raised to the negative 5 over 6. Now here the problem, we've got to turn this upside down. So this is 3 to the power of 6 divided by 2 to the power of 6, and that's all raised to the positive 5 over 6. Now if we have already done that part there, we can safely say here 3 to the 6 multiplied by 5 over 6 divided by 2 to the 6 multiplied by 5 over 6, and we cancel that and we cancel that, so we have 3 to the power of 5 divided by 2 to the power of 5, and of course we already know that basically 3 to the power of 5 is going to give us an answer of 243, and of course 2 to the power of 5 is going to give us 32. All right, so our final answer is 243 over 32. All right guys, that brings us to the end of this video and exercise. I hope this was to your benefit, and I really hope that you enjoyed and you understand the content. If so, go ahead and smash the subscribe button, drop a like on the video, and leave a comment. And if you have any other problems, be sure to link me. My contact is in the description box below. And you do take care until I see you next time in another video tutorial. Apex Elenio saying goodbye for now.